NISAR is a game changer for a number of reasons. One is it's the first dual frequency, both L-band, which is a 24 centimeter wavelength radar, and S-band, which is a 13 centimeter wavelength radar, dual frequency system that will comprehensively cover the land and ice masses of the Earth every 12 days from the ascending part of the orbit and descending part of the orbit. That means that effectively every 6 days, about once a week, we'll have a full map of these rapidly changing areas of the world. No other mission really has that in their plan. No mission has these two frequencies, and actually no other mission freely gives the data available to the scientists. The data will be available to the US public as well as the world. All NASA data in the Earth science domain go into the NASA archives, and they have a policy to release all of these data to the world.
NISAR stands for NASA ISRO Synthetic Aperture Radar. So it's sort of an acronym of acronyms, since NASA and ISRO are also acronyms. It's gone through a whole bunch of different names, and finally, when we found our partner in India, we decided to think up a name together and came up with NISAR. NISAR has 3 science disciplines, and so we have goals in each of them. Number 1, we want to understand how the ice and permafrost areas on the Earth are changing at a seasonal level, meaning growing or shrinking. 2, we want to understand how the Earth is deforming, and I mean the land structure of the Earth, how it's changing, and that includes understanding fault lines and how the tectonic plates are moving with relationship to each other. And then the 3rd one is in this ecosystem structure or biomass, understanding how the leafy parts of the Earth are growing or shrinking in the seasons. And so it's really change in those 3 science areas.
We're actually measuring the change in the position of the Earth from one time to the next down to centimeters or millimeter kind of accuracy. So as the Earth slowly moves from one time to the next, we're tracking that change as though we had a ruler from the spacecraft down to the ground with an accuracy down to millimeters. So as we're measuring that change for the solid Earth, for earthquakes and volcanoes, we're actually tracking the stresses as they change, and by virtue of a long time series over the life of the mission, we'll be able to improve models for how the Earth is moving and perhaps forecast where the stresses are building up and where they're likely to be released in the future. If not prediction, forecasting will definitely be improved by virtue of the improvement of the models.
It might not have the whiz-bang factor of a mission going to Europa or finding aliens in another galaxy or whatever, but this is so important for the Earth and for humanity. I mean, there are many applications for this specific data set that are applicable in forestry research, in crop inundation, in water resource management, shipping lanes in Canada, with ice and how the ice shrinks or grows. And we talked to one scientist who said, oh, this data set will help me understand how clouds of locusts migrate over the Sahara Desert. And I'm like, how can the same data set tell you about bugs in the Sahara and leaves in the Amazon and ice in shipping lanes in Canada? And it's really amazing that this one data set can service so many different science communities. And it's sort of the beauty of this huge amount of data that will be produced with this mission.